Welcome back to the deep dive. Ever wonder what's going on behind the scenes when you see an ad online?
Yeah.
Today we were going deep
Okay.
into the world of planet-scale ad event aggregation.
Sounds good.
Get ready to uncover the secrets of the systems that track
Whoa.
billions of ad interactions every single day.
Okay, so we're talking about,
It's really a lot.
yeah, a global network,
Yeah,
billions of events,
right.
and all of this happening at, like, lightning speed.
It's really quite fast.
Yeah.
Where do we even begin to unpack something this complex?
Well, it's a bit like solving a giant puzzle.
Oh, okay.
But let's start with the foundation. The Lambda architecture.
Okay.
Imagine you have two lanes on a highway.
All right.
One is built for speed, getting information quickly,
Okay.
even if it's not perfect.
Uh-huh.
The other lane is for accuracy,
Right.
making sure we capture everything in detail.
Okay.
Even if it takes a little longer.
Mm-hmm.
That's what the Lambda architecture does for data.
So we have a two-lane data highway. But how do we get all that data onto the highway in the first place?
That's a great question.
Is there like a
Think of digital toll booth.
edge collection services?
Okay.
These are like outposts stationed across the internet,
Interesting.
capturing data as close to the source as possible.
Oh, I see.
Imagine them as tiny little data collectors on servers
Okay.
and devices worldwide, grabbing information about those ad interactions.
Okay, so these outposts are grabbing data from every corner of the internet.
Yeah.
What happens next?
Well,
Do they send it all to, like, some massive central server?
you're right. Sending everything to one place would be a recipe for disaster.
Yeah, I can only imagine the potential for digital gridlock.
That's where Apache Kafka comes in.
Okay.
It's like a superhighway designed specifically for data.
Wow.
It can handle the insane volume and speed we're talking about.
Okay.
For example, Microsoft uses Kafka to handle a staggering 30 million events every second.
30 million events per second.
That's a lot of data.
That's more than I can even comprehend. Yeah.
But with all that data rushing around, how do you prevent the system from crashing? It seems like one popular ad could bring the whole thing down.
That's where the clever engineering comes in.
Okay.
Think of how dividing a highway into multiple lanes helps traffic flow more smoothly.
Right.
That's essentially what we do with data partitioning.
Okay.
We split the data stream into smaller, more manageable chunks.
Oh, so data partitioning is like creating express lanes for those high traffic ads.
Yeah, that's a good way to think about it.
But what happens if there's an accident on the highway? Or, to bring it back to our topic, what if part of the system goes down?
Mm-hmm.
We're talking about potentially losing a massive amount of data.
That's a critical consideration.
Right.
And thankfully, these systems are incredibly resilient.
Oh.
Data is replicated across multiple servers and locations.
Okay.
So even if one part goes down, the rest can keep running.
So it's kind of like a backup.
Exactly,
That's
that kicks in. It's like having a backup generator that kicks in when the power goes out.
Oh, okay.
You might experience a flicker, but you won't be left in the dark.
Huh.
In fact, Adform, a company that runs 9 data centers worldwide, boasts a remarkable 99.999% uptime.
99.999% uptime.
Practically bulletproof.
That's incredible.
Yeah.
So we've captured all this data and made sure the system can handle any hiccups.
Right.
But where do we actually store all this information?
Oh.
We're talking about like warehouses filled with servers?
Not quite that dramatic,
Okay.
but you're on the right track.
Right.
We use 2 main types of storage, the hot path and the cold path.
Okay.
The hot path is for real-time insights.
All right.
Imagine a dashboard showing live updates of how an ad campaign is performing.
Okay.
That data needs to be accessible instantly,
Yeah.
so it's stored in the hot path.
Okay. The hot path is like the express lane
Yeah.
for data that needs to be accessed and analyzed immediately.
That's a good way to put it.
But what about the long-term data?
Right.
Are we keeping every single ad interaction forever? It seems like that would require an astronomical amount of storage.
You're right. Storing everything forever wouldn't be practical.
Yeah.
That's where the cold path comes in.
Okay.
Think of it like a massive, well-organized library for data.
So like a data archive?
We call it a data lake.
Data lake.
All that raw data goes into the data lake where it can be kept safely
Right.
for future analysis, even if we don't need it right away.
So we have the hot path for real-time insights and the cold path for long-term storage.
Exactly.
But how do we actually make sense of all this data? I can't imagine sifting through a data lake is an easy task.
You're absolutely right. It's not about searching through raw data.
Right.
It's about turning that raw data into something useful.
Okay.
That's where data warehouses come in.
Okay.
Imagine taking all those ingredients from the data lake
All right.
and using them to cook up a delicious meal.
Okay.
The data warehouse is like the kitchen, where we transform raw data into reports, summaries, and insights.
That's a great analogy. So we have the raw data in the data lake, and then the data warehouse transforms it into something we can actually work with.
That's right.
But this brings up an interesting question. How do those real-time dashboards get updated if some of the data is sitting in this cold storage? It seems like there would be a delay.
You've hit on a key point.
Yeah.
It's all about finding the right balance between speed and accuracy.
Okay.
The system cleverly blends real-time data from the hot path with pre-calculated data from the data warehouse.
Yeah.
So you might see today's clicks updating instantly,
Gotcha.
alongside last week's trends, which were already processed and ready to go.
That makes sense. It's like having a chef who can cook a dish on the fly while also having a perfectly prepared meal ready to serve.
That's a great way to think about it.
It gives you the best of both worlds.
Yeah.
But this whole discussion makes me think about something I've always wondered.
Yeah.
How do those ads seem to know exactly what I was just looking at?
Yeah.
Are we about to dive into the world of personalized recommendations?
Absolutely. And getting those recommendations right often comes down to something called sub-second aggregation.
Sub-second aggregation.
It's all about processing data incredibly quickly.
Okay.
Think fractions of a second.
Wow.
To create a truly personalized experience.
Sub-second aggregation. That sounds intense. Why is speed so crucial in this case?
Imagine you click on an ad for a pair of shoes you were browsing.
Okay.
On the next page you visit, you see an offer for a discount on those same shoes. Or maybe a suggestion for similar styles.
Right.
That's sub-second aggregation in action.
Wow. That's impressive.
Yeah.
It really does feel like magic sometimes.
It's pretty cool.
But does every single interaction get processed that quickly?
Well,
It seems like the system would be constantly overloaded trying to keep up with everything in real time.
you're right.
Yeah.
It's not about instant processing for everything.
Okay.
Sometimes we can afford to relax those latency requirements,
Yeah.
especially for tasks like fraud detection.
Wait, fraud detection can afford to be a little slower?
Yeah,
I would think catching those bad actors would be a top priority.
it is a priority.
Okay.
But thankfully, a few seconds delay won't make a difference in most cases.
Oh, I see.
Think of it this way. Would you rather have a slightly delayed fraud alert or have the entire system grind to a halt trying to analyze every single event as it happens?
Okay, I see your point.
Yeah.
So how do you decide what needs to be lightning fast and what can afford a little more time?
It's all about choosing the right tool for the job.
Okay.
For those time-sensitive tasks like personalizing content based on a recent click, we need tools like Apache Flink, which is designed to handle something called stateful operations.
Stateful operation.
It's like having a system that remembers what just happened
Oh, okay.
and can use that information to make decisions on the fly.
So Flink is like the short-term memory of the ad tech world.
That's a great way to think about it. But for tasks that aren't as time-sensitive, like analyzing overall trends
Right.
or catching fraud after the fact, we can use a technique called microbatching.
Microbatching.
It's like grouping those events into little bundles and processing them together.
Okay.
It's more efficient and less resource intensive.
Microbatching. So instead of reacting to every single event individually, the system takes a step back and looks at the bigger picture.
Exactly. And here's an added bonus. Allowing a bit of a delay can actually save money.
Oh, okay.
We don't need to have the system running at maximum capacity all the time,
Gotcha.
which reduces the need for expensive hardware.
It's all about finding that sweet spot between speed, efficiency, and cost effectiveness.
You got it.
Makes sense. But let's get back to those personalized recommendations.
Sure.
How does the system actually create a profile of my interests?
Well,
It's not like it can read my mind, right?
it can't read your mind literally,
Okay, good.
but it's constantly learning and adapting based on your online behavior. Imagine a notebook that keeps track of every ad you click on,
Okay.
every website you visit, every product you view.
Yeah.
That's essentially what the system is doing.
Okay.
It's building a profile of your interests based on your online activity.
So it's like a digital detective constantly observing my online movements.
In a way, yes.
I have to admit, that's a little unnerving.
I understand that concern,
Okay.
but it's important to remember that this happens in real time.
Okay, so the system is gathering all this information about my interests.
Right.
But how does that actually translate into showing me different ads? And how do they make sure it's not overly invasive or creepy?
You're right. It's all about finding that balance.
Yeah.
The system acts like an online feature store,
Online feature store.
providing data to the algorithms that decide what ads to show you.
Okay.
Think of it as the system supplying the ingredients
Right.
and the algorithms doing the cooking.
Okay.
And of course, privacy and user consent are crucial considerations in this whole process.
So it's not just about randomly showing me ads. There's actual logic and data-driven decision-making happening behind the scenes.
Absolutely.
Okay.
The system is designed to show you ads that are relevant to your interests
Right.
based on your past behavior and preferences.
That makes more sense.
And if you ever indicate that you're not interested in something,
Okay.
like by clicking not interested on an ad,
Yeah.
the system will take note and adjust accordingly.
Oh, that's cool.
It's about creating a more personalized and enjoyable experience
Okay.
while also respecting your choices.
That definitely makes me feel better. So it's not just about showing more ads, but about showing better ads.
Exactly.
Ads that I might actually find useful or interesting.
In fact, Adform found that moving to real-time personalization significantly boosted their campaign performance.
Wow.
It's a win-win situation. Better results for advertisers and a more relevant experience for users.
Okay, I'm starting to see the appeal. But let's face it, wherever there's money involved, someone's going to try to game the system.
It's true.
How do they catch the bad guys in the ad world?
You're talking about ad fraud,
Yeah.
and it's a constant battle.
Yeah.
But thankfully, the system we've been discussing is built to combat these shady practices.
So how do they actually catch these fraudsters? Do they have, like, a digital lie detector test for ads?
It's more like having a team of expert detectives who are constantly analyzing patterns and looking for anomalies.
Okay.
We use a combination of real-time and historical data.
So if someone were to suddenly click on, like, 1,000 ads in a minute, that would raise some red flags.
Absolutely. The system would pick up on that unusual activity immediately.
Okay.
It's looking for things like sudden spikes in activity from a single source,
Right.
unusually high click-through rates,
Yeah.
or any other patterns that deviate from what we consider normal behavior.
So it's not just about looking at individual actions, but also the bigger picture and the context surrounding those actions.
Exactly.
Yeah.
And here's a fascinating detail. The system can actually fork the data stream, creating a separate channel dedicated to fraud analysis.
Okay.
This means the fraud detection process doesn't slow down the main system at all.
So it can kind of multitask.
It's like having a dedicated team working behind the scenes to investigate those suspicious cases.
That's incredibly smart. So the system is not only working to show us relevant ads, it's also working hard to keep the whole ecosystem honest.
You got it.
It's good to know someone's looking out for the good guys.
Yeah.
But we've been talking a lot about tracking and data,
Right.
and I have to admit, it all sounds a little Big Brother-ish.
I understand.
How do we know our privacy is actually being protected?
That's a crucial question.
Right?
And one that's taken very seriously in the world of ad tech.
Okay, yeah.
These systems are designed with privacy in mind from the ground up.
So they're not just tacking it on as an afterthought.
We call it privacy by design.
Privacy by design. Okay, I'm intrigued. Tell me more. What does that actually look like in practice?
It means we're only collecting the data that's absolutely necessary to provide the service. We're using techniques like pseudonymization,
Pseudonymization.
which replaces your real ID with an anonymous token
Gotcha.
to protect your identity.
Okay.
And we're making sure that users have control over their data.
Right.
They can opt out of personalized ads
Okay.
or even request to have their data deleted entirely.
So if I decide I don't want my data used for personalized ads,
Yeah.
does that mean I won't see any ads at all? Honestly, I wouldn't mind that.
You'll still see ads,
Okay.
but they won't be tailored specifically to you.
Gotcha.
The system might still track impressions for overall statistics,
Okay.
but it won't use your data to truly predict what you might be interested in.
Okay, that makes sense. It's not about eliminating ads altogether,
Right.
but about giving us more control over how our data is used.
Exactly.
All right.
That's the goal.
Makes sense.
Yeah.
Okay, that makes sense. It's not about eliminating ads altogether,
Right.
but about giving us more control over how our data is used.
Exactly. That's the goal.
Makes sense.
Yeah.
This has been fascinating.
Yeah.
But I have to ask,
Mm-hmm.
what kind of technological wizardry is powering all of this?
Well, it is complex,
I
but
bet
that's part of what makes it so interesting.
Yeah, I can see that.
We're talking about a whole orchestra of technologies,
Wow.
each playing its part to make this ad tech symphony work.
Okay, I'm ready for the conductor's breakdown.
All right.
Give me the highlights.
Okay.
What are the key instruments in this data orchestra?
One of the stars of the show is Apache Kafka.
Okay, I've heard of that.
It's like the conductor,
All right.
making sure all those data events are flowing smoothly and reliably between different parts of the system.
So Kafka's keeping everything in sync,
Yeah,
making sure the music doesn't fall apart.
exactly. Then we have Apache Flink.
Click, okay.
Think of it as the virtuoso violinist,
Right.
capable of handling those stateful operations we talked about, making split-second decisions based on the most up-to-date information.
Flink is our real-time improviser then,
That's a great way to put it.
reacting to every note as it's played.
Yeah.
Cool.
And for those lightning-fast analytics queries,
Mm-hmm.
we have Apache Druid.
True.
It's like the master pianist, able to analyze huge volumes of data
Wow.
and answer complex questions in a fraction of a second.
Druid is our data virtuoso then,
Precisely.
finding patterns and insights in the blink of an eye.
Yeah, that's a good way to put it.
And of course, we can't forget about the data lakes and data warehouses.
Right.
They're like the sheet music library,
Exactly.
storing all the information and making sure it's organized and accessible.
That's right.
So it's a truly collaborative effort,
It is.
with each technology playing its part to create this incredible symphony of data.
That's a great way to think about it.
And it's important to remember there are alternative approaches as well,
There are.
like the Kappa architecture,
Yeah.
where everything is done in real time,
Right.
or cloud services that can handle some of the heavy lifting.
Mm.
So it's not a one-size-fits-all solution.
Nope.
There are different ways to compose this ad tech masterpiece.
Absolutely. It all comes down to finding the right combination of tools and techniques
Right.
to meet the specific needs of the system.
Makes sense.
Ah,
This deep dive has been truly eye-opening.
glad you enjoyed it.
I feel like I've gained a whole new appreciation for the complexity and sophistication of the ad tech world.
It's a fascinating space.
Any final thoughts for our listeners before we wrap up this musical journey?
Sure, just remember the scale and complexity of these systems.
Okay.
The next time you see an ad online,
Yeah.
think about the incredible journey that data has taken
Mm-hmm.
and the delicate balance between speed, accuracy, cost,
Right.
and privacy.
It's amazing how much is happening behind the scenes to make those ads appear on our screens.
It is.
Thank you for joining us on this deep dive into the fascinating world of planet-scale ad event aggregation.
It was a pleasure.
Until next time, keep exploring
Keep learning.
and keep diving deep. Okay, that makes sense.
Yeah.
It's not about eliminating ads altogether,
Right.
but about giving us more control over how our data is used.
Hashtag.
All right,
That's the goal.
makes sense. This has been fascinating, but I have to ask,
Yeah.
what kind of technological wizardry is powering all of this? It sounds incredibly complex.
It is complex, but it's also really fascinating.
Yeah.
We're talking about a whole orchestra of technologies,
Wow, okay.
each playing its part to make this ad tech symphony work.
I like that analogy.
Yeah.
Give me the highlights. What are the key instruments in this data orchestra?
One of the stars of the show is Apache Kafka.
Okay, yeah, I've heard of that.
It's like the conductor of the orchestra,
Okay.
making sure all those data events are flowing smoothly
Okay,
and reliably
right.
between different parts of the system.
So Kafka is keeping everything in sync,
Yeah, exactly.
making sure the music doesn't fall apart.
Exactly. Then we have Apache Flink.
Flink, okay.
Think of it as the virtuoso violinist, capable of handling those stateful operations we talked about,
Right.
making split-second decisions based on the most up-to-date information.
So Flink is like
Yeah,
our real-time improviser,
that's a great way to put it.
reacting to every single note as it's played.
Yeah, exactly.
That's cool. And then for those lightning-fast analytics queries,
Right.
we have Apache Druid.
Apache Druid, yeah.
Okay, what is that like?
It's like the master pianist,
Okay,
able to analyze huge volumes of data and answer complex questions
wow.
in a fraction of a second.
So Druid is our
Yeah,
data virtuoso,
precisely.
finding patterns and insights in the blink of an eye.
Yeah, that's a good way to put it.
And of course, we can't forget about the data lakes and the data warehouses.
All right, those are essential.
They're like our sheet music library, storing all the information and making sure it's organized
Right.
and accessible.
That's right.
So it's a truly collaborative effort, with each technology playing its part to create this incredible symphony of data.
It is. It's a beautiful thing.
I like that.
Yeah.
And it's important to remember there are alternative approaches as well,
There are.
like the Kappa architecture where everything is done in real time, or cloud services that can handle some of the heavy lifting.
Exactly.
So it's not a one-size-fits-all solution.
No?
There are different ways to compose this ad tech masterpiece.
Absolutely. It all comes down to finding the right combination of tools and techniques
Right.
to meet the specific needs of the system.
Makes sense. This deep dive has been truly eye-opening. I feel like I've gained a whole new appreciation for the complexity and sophistication of the ad tech world.
Glad you enjoyed it.
Any final thoughts for our listeners before we wrap up this musical journey?
Sure, just remember the scale and complexity of these systems.
Okay.
The next time you see an ad online,
Yeah.
think about the incredible journey that data has taken
Okay.
and the delicate balance
Yeah.
between speed, accuracy, cost, and privacy.
It really is amazing how much is happening behind the scenes to make those ads appear on our screens.
It is. It's quite a feat.
Well, thank you so much for joining us on this deep dive into the fascinating world of planet-scale ad event aggregation.
It was my pleasure. Thanks for having me.
Until next time, keep exploring, keep learning, and keep diving deep.